you're all doing well. I am recording this on Sunday just so you guys will have it extra early in the morning. So I want to talk about completing the square today as a method of solving quadratics. So we've done in the past is we've solved quadratics by factoring, right? And so we said something like this: x squared plus 5x plus 4 is equal to 0, right? And what do we say? We said, what were the factors of 4 that added up to 5, right? So we essentially said, hey, what's A, B, and C? A was 1, B was 5, and C was 4, right? We were looking for the coefficients. And we said if A was equal to 1, then we can continue. And our next step was, once A was equal to 1, we said, hey, what are the factors of 4 that add up to 5? And, you know, if you really need to, you can list them all: 1 times 4, 2 times 2, right? And 1 times 4 multiplies to make 4 and adds up to make 5. So what we can do with this is we can say, hey, let's write this in factored form: x plus 1, x plus 4. Okay? And we can go ahead and we can say, hey, x plus 1 times x plus 4 is equal to 0. Well, if when we multiply them, they multiply to make 0, well, one or both of them has to be 0, right? In other words, the only way to make 0 by multiplying, and these two things are multiplied, is to multiply by 0. So if I went ahead and I said, what makes this one equal to 0? Well, negative 1 plus 1 equals 0. So now I would plug in negative 1 over here too. That would make this 3, but it doesn't matter because anything times 0 is 0, right? And we said that there were two different answers, and that's going to be a big sticking point for us, is that there are going to be two different answers, okay? That there are two ways to solve this, okay? X equals negative 1 and x equals negative 4, okay? So that's what we have been doing, but there are some limitations to this. Say I gave you a different one. Say I said, x squared plus, oh, I don't know, 6x minus 4 equals 0. Now, we can go ahead and we can list A is equal to 1, B is equal to 6, and C is equal to negative 4. So if we took the factors of negative 4 that added up to 6, well, I've got 1 and negative 4, right? 2 and negative 2, and negative 1 and positive 4. None of these things add up to 6. None of these things add up to 6. So now the question is, are there no answers to this? Yeah, there are. There are two answers to this. The problem is we can't solve this by factoring, so there's got to be some other ways. Okay, so let's talk about completing the square and why we would want to do that. If I told you, let's go back to that original problem we looked at, 5x plus 4. Now, the reason we had a factor was there was no operation that could help us isolate x, right? There was too many things going on here with x. Forget the 4 for a second. We had an x squared and we had a 5x. So even if we subtracted 4 and subtracted 5x from both sides, you know, there's no operation that will make this possible. There's no operation that will help me separate. Even if I square rooted this, right, I would find out that x is equal to the square root of negative 5x minus 4, which is all well and good, but I still have x's on both sides. There's no way to separate that away, okay? Now, let's look at a much simpler example. What if I said x squared is equal to 9? Well, most of you guys know to undo a square, I'm going to take the square root of both sides, right? Right, and so we find out that x is equal to, well, the square root of 9 is 3 or negative 3, right? Don't forget, okay, there's two answers. So what are the two answers to this problem? It's positive 3 and negative 3. Now, this is possible because there was no middle term. There was nothing multiplied times x, right? We just had the x squared. What if I said this? What if I said x minus 2 squared was equal to 9? Well, here, I can still take the square root, right? I can still say that the square root of x minus 2 squared is x minus 2. The square and the square root undo each other, right? And I'd have two things over here. I'd have positive and negative 3, right? And then I could say, well, x minus 2 is equal to 3. And I can say x minus 2 is equal to negative 3, right? We can go ahead and we can solve. Plus 2. So we say x equals 5. And we can add 2. And we can find out that x equals negative 1. All right? So there are solutions to this. Now, let's keep those answers, but let's go back to our original problem. Well, what if I went ahead and I wrote this all the way out? Well, you guys know how to multiply things by themselves. X minus 2 times x minus 2, right? And we're going to go first, outer, inner, last, right? First, outer, inner, last is equal to 9. So I have x squared minus 4x plus 4 is equal to 9. Well, again, had we started from the get-go with this, we can go ahead and we can get it from this form to this form, right? Now, in this case, we could have factored this, right? We could have factored this. But completing the square is going to give us a way to solve things that are not factorable, like some of those ones I was showing you guys before. Now, we're going to focus on that tomorrow. Today, we're going to talk about ones that are factorable, ones that will have integer answers. But just be aware that, did I leave it up here? I did. Sorry. If I were to give you something like that problem I put up there before, we can go ahead and we can put this as a perfect square and help us solve it. Okay, something that's not factorable. So the reason we really want to know how to complete the square is that it will allow us to solve questions that we currently can't solve. Okay, now I want to get down to basics first. I really do. So let's focus on a few examples and we'll talk about how this is beneficial to us. Okay, so if you'll recall from last time, if I wanted to make something a perfect square, okay, what I wanted to do was I wanted to take my b term, divide it by 2, and square it. We were doing that on Friday, right? So in this case, your b term, well, a is 1, b is 6, and we don't have a c term right now. So what we're going to do is we're going to take our b term, divide it by 2, and square it. So 6 divided by 2 is 3, and 3 squared is 9, okay? But if I'm going to go ahead and add 9 over here, we got to make sure we add 9 over here as well. Okay? So now this is a perfect square. This is a perfect square, okay? Oops, okay? Good. Now the benefits of that are I can rewrite this side right here as a perfect square. I can go ahead and say this is x squared, x plus 3 squared. Remember, where take the square root of this one, take the square root of this one, and the sign of the middle number. Okay. Well, good news for us, we can now take the square root of that. Okay, and now we can go ahead and we can solve, right? So let's take a look at an example here. I have step-by-step notes here, okay? Today we're going to focus on these types of problems, okay? And over the next few days, what we'll do is we'll focus on these types of problems where you see we get those complicated answers that we weren't able to get before. Okay, so let's go through this example step by step. Okay, so the first step, let's start with the problem. X squared plus 12x plus 32 is equal to 0. Okay, now the first thing we want to do is make sure a is equal to 1. So does a equal 1? Yes, it does. Once a is equal to 1, we can continue. For those of you guys who are taking geometry and looking at this video right now, it will always be equal to 1. Okay, you'll never see one without it. Okay, and for those of you guys who are in Algebra 2 watching this video, and Algebra 1 watching this video, you probably won't see one of those problems in Algebra 2. Okay, all right. Now, the first thing I would do, was go ahead and get rid of the C term. Move your C term over to the other side. I will show you an example maybe tomorrow where we don't do this, okay? But the reason is that sometimes if we're working with the numbers over here, we forget to go ahead and put them over here too, okay? And I'll show you an example of that tomorrow, okay? So really what we want to do now is now we don't have a C term. We want to know what C will make this a perfect square, okay? So again, what are we going to do? We're going to take our B term, divide it by 2, and square it. So in this case, it's 12 over 2 squared. Well, 12 over 2 is 6, and 6 squared is 36, okay? So what do we want to do? I want to add 36 here, but again, if I add 36 here, I also need to add 36 over here, okay? Still algebra, okay? X squared plus 12x plus 36, negative 32 and positive 36 is going to make 4, okay? So I'm just going to get this out of the way. So again, now we know this is a perfect square. Again, if we think about it, what are my factors of 36 to add up to 12? Square root of this one, square root of this one, sine from here. Okay, good. Now, again, the benefit of doing this is now that it's in this form, okay, our next step over here, we are here. Okay, so we can go ahead and we can take the square root of both sides, okay? You can take the square root of this side and the square root of this side, and let me tell you, this is where the mistakes are made, okay? The square root, the square and the square root undo each other, so all you're left with is x plus 6 over here. The mistake is made here. 4 has 2 square roots. It has the positive square root and the negative square root. Okay? Again, what do we need to do? We need 2 answers. Well, we have 2 equations really here, right? We have, since we have this over here as square root, x plus 6 is going to equal the positive 2, and x plus 6 is going to equal to the negative 2, okay? So you need 2 different answers, okay? Don't be intimidated by the positive and negative sign. That just means that there's 2 answers, a positive 1 and a negative 1. Okay, let's go ahead. Let's take this a step further. Let's subtract 6 from both sides here. 2 minus 6 is going to be negative 4. And subtract 6 from both sides. X is going to equal negative 8. Okay? So again, what are your steps? You're going to make sure a is equal to 1, move the c to the other side, find the new c term, add it to both sides, okay? And now you're going to go ahead, you're going to write it in factored form, take the square roots, and express your answers, okay? So again, go ahead, you can follow these steps one by one, and I'll take you through all these problems, okay? Again, we're going to be focusing on these today and these tomorrow, okay? So let's go ahead and let's take a look at a few more. Okay, so we're going to go over examples 1, 2, and 4. They're available on the website. And then tonight you guys are going to try and do 6, 9, and 10. Again, the reason we're jumping around a little bit is those other examples on there are going to be a little more complicated. We'll talk about those tomorrow. Okay, so we're going to use the sheet today and tomorrow. Okay, so again, we're going to go over 1, 2, and 4, and you guys are going to do 6, 9, and 10. All right, so let's follow our steps here. Okay, first thing, again, what's my lead coefficient? 1. E is equal to 2, C is equal to negative 3. Why it insists on writing in crayon all the time. I have tried to get it to not write in crayon all the time, no matter what I try. Okay, all right. So again, so the first step, does A equal 1? Yes, it does. Okay, right? There is no Lie coefficient here, right? It's 1. Good, so we can continue. Our second step, move your C term to the other side of the equation, right? So let's go ahead, let's add 3 to both sides, right? So now I have A squared plus 2A, okay, is equal to 3. Okay, I like to leave a little space here, so you have time because you know you're going to be writing something in there. Okay, so again, now I no longer have a C term. Right, my new C term, I'm going to take B divided by 2 and square it. Okay, in this case, that's 2 divided by 2 squared, which is 1 squared. 1 squared is 1. Okay, but again, if I'm going to add 1 here, I got to add 1 over here as well. Okay, so again, what are we going to have? A squared plus 2A plus 1 is equal to 4. Okay, you'll notice with all these examples, this is going to be a perfect square. Okay, all right, again, we know this is a perfect square because we made it a perfect square. Let's take this square root of the first term, square root of the last term. Okay, so square root of A squared is A, the square root of 1 is 1. Let's take the sign of this middle one. Okay, good. Good. We went ahead, we added 1 to both sides. We now have it written in a perfect square form, correct? And now let's take the square roots of both sides. Okay, so the square root of this side is going to be A plus 1, and the square root of 4 is, don't forget, positive and negative 2. Let's set up 2 equations. A plus 1 is equal to 2, and A plus 1 is equal to negative 2, right? And now let's go ahead and let's solve. A is equal to 1, and A is equal to negative 3, okay? So again, what do? We made sure A was equal to 1, check. We went ahead, we moved the C term over to the other side, check, okay? We went ahead and we determined, we said B divided by 2 squared, so in this case it was 2 divided by 2 squared, so 2 divided by 2 is 1, 1 squared is 1, we added 1 here, added 1 here, good? The next thing we did was we turned this into perfect square form, okay, and that's what we said here, okay? And then our last step was to we took the square root and then we went ahead and solved for both sides, okay? All right, again, A is equal to 1, so we can continue. Again, if you guys are comfortable enough that you don't need to write this every time, that's totally fine, okay? So again, A is equal to 1, let's go ahead and let's move that 8 over to the other side, okay? So now we have no C term. We have A squared minus 2A is equal to, again, leave a space, 8. Hold on, timeout. Sorry about that. Okay. And again, what are we going to do right here? We're going to say B over 2 squared. Okay, so that's negative 2 divided by 2 squared, which is negative 1 squared. Be careful, negative 1 squared. So negative 1 squared is 1. This number here should always be positive, since you're squaring in your last step no matter what. So be careful if you're putting in your calculator. Okay, make sure of that, okay? But again, if we add 1 here, we got to add 1 over here. So what do we got? We got 8 squared minus 2A plus 1 is equal to 9. All right? Erase this for a little more room. Okay, again, what's our next step? We want to rewrite this into a square root form. So a perfect square form, rather, okay? So what are we going to do? Square root of this one, square root of this one, sine of this one. Again, this one is negative, okay? Okay. Now, take the square root of both sides. Make sure you have a positive and negative number over here, okay? So A minus 1 is equal to the square root of 9 is positive or negative 3. Okay, and our last step, let's split that into 2 problems. A minus 1 is equal to 3. A minus 1 is equal to negative 3. Let's add 1. A is equal to 4. And add 1. A is equal to negative 2. Good? So we're going to skip 3 because 3 is a little more complicated. We're going to go to number 4, and then we'll call it a day. Okay? So again, we'll do this one without writing every single thing down. Does A equal 1? Yes. So when we continue, absolutely. Our next one, let's move the 12 over to the other side. So let's subtract 12 here, subtract 12 here. Okay? So now I have k squared plus 8k is equal to negative 12. Okay, again, what do I want my new c term to be? 8 divided by 2 squared. 8 divided by 2, 4. 4 squared, 16. Let's add 16 here and add 16 here. I will be totally honest with you guys. Wherever I make my mistake is right here. I always forget to add, so don't be like me. K squared plus 8k plus 16 is equal to 4. Okay. Again, what is this in factored form? Square root of the first thing, square root of the last thing, square root of 16 is 4, and the sign in the middle number. Okay? So again, next step, we're going to take the square root of both sides. So what do we end up with? I'm going to write it over here. K plus 4 is equal to the square root of 4, don't forget, positive or negative 2. Okay, now we need two answers. K plus 4 is equal to 2. K plus 4 is equal to negative 2. Subtract 4 from both sides. K is equal to negative 2. Subtract 4 from both sides. K is equal to negative 6. Okay, so again, we got our two answers there. All right? So listen, I know this is kind of a tricky process. I know that a lot of you guys in geometry were probably hoping to forget this, but I did warn you guys last year that it's something you guys need to remember how to do. Hence, we're going to take a few days to go over it, okay? But anyway, like I said, there's a straightforward process. You can download the notes. You can take a look at them. And I will talk to you guys tomorrow. Thank you.